Welcome back to 14 Minesweeper variants. Yeah, alright, Minesweeper variants. Time to continue with the gallery. Yeah, time to continue with the gallery. I'm gonna try to reach 49 eventually. Alright, so, group area. It's a bunch of combinations of puzzles now, of variants now. Each continuous mine region is of size 4, so mines, have to form regions of size 4. Simple enough. Area means clues represent the total sum of areas in those mine regions authority connected to it. So this 7 sees a 5 and a 2, making it a 7. So this 0, for example, will see 0 and 0. Same for this 0. Same for these zeros. And this 0. Same for that 0. Anyway, this 4 must see 4, so this has to come... it has to touch a region of 4, basically, which must continue extending out. Now, we can say that this can't be a mine, because if it were, then, this would have to sum to a region of 4, which itself cannot happen. This 4 means this has to come out here, which means one of these have to be mines. I'd say that a mine here is pretty convenient, because that solves a lot of the puzzle. Otherwise, though, if this mine went out this way, I guess this is never a mine then. Cool. 8, so this sees 2 mine regions, which means there must be a mine in one of these cells. In fact, if this ever happened, then how would this 8 see something? I mean, if this happened, then this can't be a mine to reach outwards, which would require this. Although I guess this is somewhat valid. And if it were the other way around, I'm pretty sure that also implies that this is not mine. Fair enough. So now we know that yellow is wrong, because we already saw that yellow gives this a wrong number, so it must be how red goes. That's empty. 4 means that's a mine. 8 must touch extra, so must this 4. This can't be empty, because it must have a region of at least 4. Of exactly 4, in fact. I guess one of these have to be mines, because if they were both empty, this 4 would... this would have to be a region of 3 at most. Because one of these are mines, and this 4 will already touch a region of 4 here, meaning that none of these are mines. Okay, we got a lot of zeros as a result. This has to have a mine there, which must extend outwards. This 8 must see 2 separate regions of 4, which must mean that it must touch mines in both of its empty sites. Okay. There's a total of 5 regions of 4 because there are 20 mines total. So we've accounted for 4 regions so far. There's a 5th region somewhere. This can't be a mine because if it were, it will grow outwards, making a region of 5. And now this 4 must have a mine here, which must grow outwards. So that's 1 region done. This sees 4 here, must see another 4 here, so this can't be a mine. And 0 means that this is where your last region comes in. This means that's the mine that's empty. And so this region now can never reach this cell. So that's empty. Now this must be a mine, and the only way to have these connect is through this cell. There you go. And with 2 mines remaining, these are both just mines. Nice. Alright. Group isn't that hard area isn't that hard with a group helping around, I guess. It was really just the beginning portion where I had to map out 2 different possibilities. And that was mostly it. Okay. Oof. Oh, flower. Jeez. Alright. Liar, flower. So, let's start with liar. It's actually the easier one. Basically, a liar is a number that's either 1 more or 1 less than its actual value. So this 3 could either mean 4 or 3. Yeah. And every word in column has exactly 1 liar. So the rest are telling the truth, basically. All mines. Mines are also counted as non-liars. Anyway, next up is flowers, where each colored cell mine has exactly 1 non-colored cell being a mine around it. So this mine has exactly 1 of its 4 neighbors being a mine. And same goes for all of these valid mine positions. Okay. Let's start with the 0. Yes, this can't be mine and this can't be a mine, because if they were, this 0 is just a 1. And because this 0 can't be any bigger than a 1, these are both empty. Now this mine will no longer have a partner in its non-colored cells, in its non-colored neighbors, so it therefore doesn't work. So these can't be mines. Cool. Okay, well 1, 0 is definitely telling me that something's wrong here. one of them have to be liars. They are either both 0 or both 1s, because this can never be more than this. And if that's the case, these are both empty. But also that means that because there's a lie in one of those cells, the remaining cells in the row are never lies. Cool. Okay. So these are alternate truth. 5 and 2. Well, I suppose this has to be a mine. Because if it wasn't, then 5 and 6 cells implies that one of these sets of 3 must have all mines, right? Because you can only have one mine and one empty cell and everything else has to be a mine. One empty cell and the rest have to be mines. So what that would therefore imply that in any case there's always going to be one set of 3 that's always mine, which breaks because the middle cell would be a colored mine touching 2 non-colored mines. So this has to be a mine, which means one of these are mines. In turn implying that there are 3 mines in here. 3 mines in here. Now this 2 is actually completed by this set, so these are both empty. Meaning 1 mine in here, therefore this 0 must be a lie. This 1 means there are no mines there. 3, 2, 2, 1, 2. 4 is interesting. We don't know if this 4 is telling the truth or not. If this 4 was a... Oh, this 4 can't be a 5, right? So it's either a 3 or 4. If this was a 4, then it can't be here, 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 and here because this mine would be broken. Therefore, there has to be a mine there. I guess the 1 could be a liar, it could be a 2. I guess we don't really know. But we do know the 6 is telling the truth though. What does that say? What does that say? I think it says that the it says the corners have to be mined, right? That's what a 6 means. Because suppose this was not a mine. Or if that were to happen, then the 6 must have at least 3 of these be mines, right? And if there were 3 mines out of the 4, then we can say with certainty that one of this set is gonna happen. In which case, you either have this or this or this in your 3 out of 4 of these being mines, which would then further make this not a mine, and that would cause everything else to be a mine, which then clearly breaks. So yeah, I guess that would therefore imply that the 6 must have mines in all 4 corners. There's only 1 mine here, therefore there will only be 1 mine in there. That would then imply, there's also 1 mine here and only 1 mine in here. That would then imply that this isn't a mine and this isn't a mine. Okay. Now this 2 and this 1 see the same number of mines, right? Because this 2 sees 1 mine plus whatever's in here. This 1 sees 1 mine plus whatever's in here. So they must be the same value if they were both non-liars. But because they're different, one of them has to be lying. So everything else in the row is correct. This 4 is correct, meaning those are both mines. That's empty. This one sees 1, so those are empty. Cool. I think either case this has to be a... No, wait, hold on. These could both be empty. Yeah. This can't be empty though. Because if it were empty, then this 4 must be a 3, putting a mine here and here. This mine is now broken. So, this must be a mine. Therefore, these are both empty. Therefore, that's a mine. Therefore, this is empty. We now know that the 2 is lying and the 1 is telling the truth. There's a mine there which must grow outward because of flower. 3 is telling the truth, so that's a mine. Meaning that's not. 2 is telling the truth, so that's empty. 3 means one of these are mines. 2 we don't know. Neither we do know about 1. Okay, the 5 must have 3 in these 4 cells, but they can't both be here, right? Otherwise, this middle cell will be broken. So these are both mines, therefore that's empty. And there's one mine in here, which I can probably mark now. There's one mine in those cells. If this 2 was a lie, it would be a 3, putting a mine here, but then that fails this 1, because this 1 already sees one mine there. That will make 2 and 3 both lies, or this 1 and 2 both lies, which fails. So this 2 must be telling the truth, meaning that these are both empty. Therefore there's a mine here. 1 we still don't know, but we do know from the column that this is a mine, liar, sorry. Which now means that, because this 4 is a lie, it can't be a 5, it must be a 3, so that's empty. 3 is telling the truth, so those are both mines, making this 1 a liar. 5 is telling the truth, so there's one mine in here. But it could be anywhere. Okay, one of these are lies. Well, this 4 is telling the truth, so these are both mines, therefore this is a lie. Well, this must be a mine there, and therefore this 3, which is a lie, is probably just a 4, so that's empty. 5, well, these can't both be mines, because then this middle cell will be broken. So there must be a mine here. And then I guess either of these could be fine as a mine. We're getting somewhat close, I think. If this 0 is telling the true, no, sorry. Well, I mean, there's one mine here, we know that. But this 4 could be a liar and put a mine there. Or this 4 could be telling the truth, making this a non-mine, making that a mine. If this is a mine, then this is empty. But we don't know what that means. If this is a mine, then this is empty, this is empty. But in the other case, this could be a mine. If this is a mine, then these are both empty. Therefore, this is a mine here and a mine here. Also forces this to be empty and a lie. But that fails because now this 0 has a mine here, which would make 0 a lie. And now row 8 has 2 liars. So it doesn't work. You can't have this be a mine. What? Oh, you can't have this be a mine. Oh, oops, my bad. Well, that sucks. Therefore that's a lie. Okay. Well, I guess we're restarting. That's really sad. I kind of forgotten. But we know these are both mines. Okay, then everything else here is true. And we figured out this 5 and this 2 must have a mine there and one mine in here, making these all empty. One mine here means these are both empty. The 0 is definitely lying. 6 has to have mines here, 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 and here, but also has this square pattern over here, which means that these are both empty. This 1 and 2 has to have a lie in one of those cells, therefore this 4 is resolved. We also know that this must have a mine here. And this must be empty, which gives us all of that. This 2 is lying, so that 3 is telling the truth, so it's empty. One of these are lies. 0, this 2 can't be lying. So that happens. 4 must be lying. This 1... this 2, okay. Wait, what? I don't remember. Anyway, these are both empty, so 4 is... oh, 4 is not done. We don't know if 4 is telling the truth or not. 1 is probably lying though. Oh yeah, because 3 is telling the truth, so 1 is lying. There you go. This is a mine, 3 is lying. And then, I think we've gotten here before. We must have mines here and here, therefore that's empty. Right, and then we figured out that this is a mine, but this can't be a mine. Which now implies that this is a liar. And because there's one mine in here, 4 being a liar must have a 5th mine, which is there. Okay, and now that's a liar, that's a liar. 0 is kind of true, so that happens, that happens. 3 means that's a mine. This must be empty. Therefore you have that. 1 mine in here means that's empty. And this my singular mine here can't be an isolated mine in a light cell or a colored cell, so it has to be there. Oof, there you go. That's your entire chain of logic to get you to this final position. Pretty cool. Unfortunately, you had to restart, but we got through it. We got through it. I don't know why I like snickered like that. Anyway. Sorry. Let's keep going. Let's do another one. Alright, bridge. Oh, bridge and cross. Well, cross is not that bad. Cross indicates the number of mines in colored and uncolored cells. These two numbers are one of each, but we don't know which is which. Bridge means that your mines, because it's an 8x8, you must have 3 total bridges bridging mines from left to right, and it must be singular. It must form a singular line of mines. So you can't have mines that connect vertically. You can't have mines that disconnect. You can't have mines that don't end. So all mines have to go from one place to another. Okay, 0, 2. If 2, 3. Well, 0, 2 and 2, 3 sum total of what, 7? I guess they do. Okay, if 0, 2 referred to the 2 dark cells, you could do something like this. We know, because of bridge, every column has a total of 3 sets of 3 mines, which is equal to 9. There are therefore 9 total cells, right? And we know there's 5 here, because 2 plus 3 is 5. And there's 2 more here. So these sum to a total of 7. Therefore the remaining cells must have 2 more total. Now, consider the fact that 0, 2 here has a few options. It's either 2 darks only, in which case this has to grow out this way. That's 1 more. Or, if it's too light, it can't be 2 lights like this, because then they will be broken. So it has to do this, plus either a connection like so, because this will be empty and this will be empty, or a connection like so. So there's always 1 mine in one of these cells, which gives you 8. The last mine is in the remaining 6 cells, which is how we get this 2, 3 to come in. How would that work? If 2, 3 were 2 darks and 3 lights, then we'd know that because one of these are mines, you'd have this happen. This can't be a mine, so it can't be a diagonal going this way, meaning that there must be a mine here, which grows out this way, right? So if 2, 3 happened, that will happen. If 2, 3 was for what? If 2, 3 was for light cells. Not entirely sure what happens next. Yeah, there's nothing much we can say about this. What else? If 2, 3 was for the dark cells. If 3 was for the dark cells, could this happen? I guess. You could have something like this. One chain goes this way, one chain goes this way. So that's really not useful. What else? Honestly, anything could happen with that 2, 3. Anything could. We have this bottom one settled. There's just 3 options, but how does that affect anything? Well, it does say that there is one mine in these 3 cells, and one mine in these 3 cells, and one mine in these 2 cells. How? Either you have this, or you have this, or you have this. All cases lead to one here, one here, one here. That might help with the 2-3 now. Because 2-3 could indicate a lot of things. Such as the fact that there must be a column with 2 mines in it. In fact, 2 of the columns in this block of 3x3 must have 2 mines in it, right? You either have this and this, or this and this, or this and this. And the reason for that is because if you only had 1 in 2 columns, then the other one would have 3, which firstly isn't even possible, but if it were possible, would break the remaining bottom area. So now what that means is that 2 of these have 2 mines in them, which doesn't seem significant, but probably is. Although I don't see how that could be significant. That does in fact leave 1 mine in this set of cells, but again, not very useful. Although maybe, if this happened, that might cause issues. Because if this happened, we'd basically have something that looks like this, right? Just have to go out this way and out this way. Now what? Doesn't really help. Although it does imply that this is definitely a mine. Which it could either do this, or I could do this, or I could do this, and all of those would fall correctly under 2-3, and that doesn't change anything about the bottom area, which we sort of already guessed. I mean, we already know the 3 possible states. What about something like this, which must happen? Then we have this, we have this, and then I guess this has to be empty, which gives us that, which is also possible. Okay. What happens if mine is here? Then I guess again this has to happen. Well, these are mines, and then there are 2 mines in here, which correspond to where these 2 are. This has to go this way. Therefore, this has to go this way. Aha. So that means this has to happen. Which again is interesting. Because this is very similar to what happened previously, right? Previously there was a mine here and a mine there. But in the very first scenario, where it was a mine in the center, which we knew had to come out this way and this way, we had nothing to go off of after that. Mine goes there, and then one of these are mines, one of these are mines, and then nothing happens. Anything could happen there. You could either have this, or this, or this. So once again, anything could be a mine in this situation, which is really sad. I just need a singular contradiction. If this was a mine, oh, then this is empty. This mine has nowhere to go. Ah, that's your contradiction. It's way easier than it looks. Okay. I just spent way too much time. There you go. Okay. Now 2-2. Well, we know there's only 1 mine in here. We know that because we figured that out. Therefore, there must be 1 mine somewhere else. In fact, there must be 3 mines somewhere else. Ah, and there's your answer. Because there can only be 1 mine here at maximum, the only way to resolve this, if these were both mines, there were no mines in here, there was exactly 1 mine here, and therefore, for 2-2, we already have 2 dark mines, we must have 2 light mines, so that's not a mine, that is. So is that actually. Which has to now go outwards. This 1 means that's a mine, therefore that's empty. So is that. Therefore that's a mine. 1-1 means that's empty. Means that's a mine, these are not. Which gives us sort of that. 1-2. We know one of those are mines, but we don't know how to figure that out. Same for this 1-2, but we know that's empty. Actually, 1, 2 already has 2 light mines, so that's not a mine, therefore that is. 0, 1 means one of these are mines, which means that this 1, 2 will be complete, that's empty. This can't be a mine, therefore that's a mine. 1, 2 already has 2 dark mines, so none of those are mines. 0, 2, well 0, 2 already sees 1 dark, so it must be 2 dark. Which means there's 1 mine in here. 0, 2 now means because there's 1 dark mine, the other has to be a dark mine as well. 1, 2, well it means there has to be at least 1 light mine, which means that's a mine. This one means there's a mine there. 1, 2. Well, they can't both be here. Because if they were both here, this would be empty and this mine would have nowhere to go. Also, you can't have 4 mines in a column. So there must be a mine there. Which now means that this can't be a mine, because this mine wouldn't be able to reach there. Yeah, and because there must be 1 mine here, this also can't be a mine. Which means that can't be a mine. Oh, what? Oh, I'm so dumb. It could come out from here. Oh, okay, well there goes all my drawings. We did figure out that this can't be a mine though. Which, I guess I'll do all the important stuff. There's 1 mine here, and then we know there's 1 in each column here. We know there's 1 mine here as a result. And therefore we can say all of this, all of these are empty. Well, these are mines, so therefore that's empty, that's empty, that's a mine. We can solve all of that. This must be empty. So must this be. Okay. That resolves most of our issues. 1, 2 means that's empty. That's a mine. That's empty. 1 mine goes here. This 1, 2. Oh, that must be empty, so that happens. 1, 2 implies those are both empty. There's 1 mine in here, so that's a mine. Those are both empty. Mine there. This one is complete. We know now that this must be a mine. Therefore, this is empty. Therefore, because one of these are mines, these must be empty as well. 1, 2 is interesting, but I'm not sure we can do that. Oh well, we do know that there are 2 mines in these 4 cells. Is that useful? I don't know. I do know that this mine has come down, so that's a mine. And then I don't know about this one. Does it go up here or does it end here? Not sure either. Not sure. No, well this mine has to go up this way, so that's definitely a mine. Now I already see 2 light cells, so that's empty. Which means that one of these are mines. But not both. So this can't be a mine, because if it were, it would have to go backwards. So this can't be a mine. Therefore that's empty, that's a mine. And now one of these are mines, one of these are mines. This mine over here now can never reach this cell. So this cell over here has to belong to this mine. They have to connect to each other in some way. Meaning that this is the second cell, there can't be 2 cells underneath. This is for the second bridge. This mine, wherever it is, would be for the third bridge, which can only be here. So there you go. That's empty. This has to be for the back here, so that's empty as well. That resolves a lot. 1, 3 is resolved. And in fact, because this is for this one, you have to connect directly like so. And that completes these rows. 0, 2 means this, and therefore there we go. Wow, what a puzzle. The beginning was definitely the tough part, huh? Very much the tough part. Okay. Well, there it is. Alright, let's do a couple more. Triplet deviation. Okay, well, let's start off with triplet. Triplet means that mines cannot form rows 3 in a row, column 3 in a row or vertical column. Non-mines also cannot form 3 in a row or column. So yeah, that's why I marked this and this with mines, because of that. 2 implies that there's 1 mine in here. For the 5, there cannot be 3 mines here. So even if there were 2 mines here, this would still have to be a mine. That would be empty. There will be 2 mines here. That will be empty. 4, 5 now differ by 2. Therefore, since this 4 already sees a mine here, 5 must see 1 more. Did I say they differ by 2? They differ by 1. This 4 sees 1 mine, so this 5 must see at least 2 mines outside. So that happens. Okay. Now we know there's one mine in here. 5, 4, 4. Well, 4, they can't all be here. You can't have 3 in this set of 3. So these must both be mines. And then there'll be 2 mines in here. Okay, well, there must be 1 mine in here due to this question mark forming 3 in a row. Therefore, this 4 will be complete. That's empty. That's a mine. 3 means that's a mine. Therefore, that's empty. Therefore, that's a mine by triplet. That's not a mine by triplet. 2, there must be at least 1 mine in here. That will complete the 2. So that's empty. Therefore, that's a mine. Therefore, those are empty. Therefore, that's a mine. Sweet. 5. Well, this 5 is similar to a 4 in here because there's 1 mine here, making this set of 6 equivalent to a 4. And we know that if there were a 4 on the side, which is basically what this 5 is, these are both mines because you can't fit 3 mines in here. That's empty. Now those are both mines, therefore that's empty, therefore both those are mines, therefore that's empty. That's empty. Okay. That's empty as well. 4. 4 sees 2 so far, therefore 1 here and 1 here. That forms a nice 1-2 pattern, meaning that's a mine and that's not. That's a mine. Okay. We now know, therefore, that there's a mine there. They can't both be here, but they could both be here, which is interesting. Okay. 5 now must see 2 more, of which we don't know. This 4 maybe? Maybe. I don't see any issue with that yet. A mine here would resolve the 3 in a row for this column entirely. And then I'm not sure. I guess we know there's 1 mine in here. Should be 1 here, 1 here. Oh, well, there should be 1 here, 1 here, and 1 here. They don't overlap, therefore it is a minimum you can have. Therefore, this is right. This 5, therefore, seeing 1 here must see another 1 there for 5. That's empty. That's a mine. That's empty. That's a mine. That's empty. There must be a mine there, which means that with a mine here finishes the 3. Therefore, those are both empty. That's a mine. That's empty. That's a mine. Therefore, that's empty. 4 means there's a mine there. That's complete. 1 mine in here. We know from these 2 cells that there's a mine there. That's empty. With 2 mines remaining. Boom. Sweet. Okay, very cool. Next up. Horizontal encryptor. Well, horizontal means that all mines must have a partner horizontally. They must have something touching it horizontally. As the mine, I mean. And encrypted means numbers are encrypted by letters, which should be simple enough to understand. Okay, well, starting with horizontal, we know that those are both definitely non-mines. We can therefore have a few possible values. Starting with the fact that G and B are at most 2 each. Well, I do know that G is greater than B, because we see here, G sees whatever B sees plus something. And knowing that G cannot be equal to B, it must therefore be greater than B. So G now can't be as high as a 0, it can't be as low as 0, B can't be as high as a 2. This can't be a mine, because if it were a mine, it would need a partner forcing B to become a 2, which fails. And now we have G again. H is greater than G, so H can't be 0 or 1. H is at least 2. Okay, this now can't be empty, because if it were empty, this will also be empty by horizontal, meaning G is 0, which fails. So this can't be empty. If B is a 1, G is just a 2. How does that work out? Mine here, mine there. One mine in here. This G can't have a mine there because it would be empty. So we have to have a mine here and a mine there. One mine over here implies they're both empty. H must therefore be 3 because it has to be greater than G. Which gives you this, which is somehow valid. Yeah, this is valid. I guess this works. If G was 1 and B was 0, then no mine here. G can't have a mine there, so my mine must go here. G, there's only one mine, so that happens, which means that's a mine. H is now greater than G, but can only be 1 greater, so H can't be 4 or 5 anymore. But H could still be 2 or 3. So this also works. Cool. Oh, right. Now B over here tells us that because it's a maximum value of 1, these can't be mines. If this were a mine, then this would be empty, which fails. Same for this B. I guess H and C now give us new values. But B... How does that help us? If B was 0, then I guess... If B was 0, H is forced to be a 2. G is forced to be a 1, and now what can C be? C can see a maximum of 2 cells. But C can't be 0, 1, or 2 because B, G, and H all take them up. That fails. So B now can't be 0. B is 1, G is 2. Cool. This must have a partner. Must be like this. Alright, H has a value now, H is 3. E is at least 2. C, we don't know about C. 3 and 1 works. Gives us that. C is either 0 or 4, but we already know C is 0 because C can't be 4. Nice. That happens, this must be a mine. F must be at least 4, but can't be 7, fair enough. One of these are mines. 1 implies that both of those are non-mines. 2 is complete. Either D is 7 or A is 7, but we haven't seen any of those yet, so I guess we don't know. 2 and E. If E was 6, you have to have a mine here, 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 and here. That will force both of these to be mines by horizontal, which fails this 1. So E can't be 6. If E were 5, then similarly, because none of those can be mines, they can't both be mines. You only have one mine in here, which implies this. All of these would be mines, this would be empty. But this, I think, works. Okay. I mean, F has nothing much. Well, 3 must have one of these be mines. That must have a partner here. That will complete the 2, so none of those are mines. Aha. Alright. E and 3. Well, there must be... Well, either these are both mines or they're both non-mines. Because they can't have only one mine here. So this either has 2 mines in it, or has 0 mines in it. And you have something that looks like this. Well, that will fail because E is at least a 4. This makes E a 3 at most. So that fails, meaning there has to be at least some number of mines here, therefore these are both empty. Cool. This has to be empty. This 2, I don't know how that works. E, we know is at least a 4, but we don't know what E actually is. 3 is 2, but... Okay, well, we got 4, so there you go. F is 5. 2 and 4. Well, this can't be a mine because this will be empty. 2 and 2 share the same number of mines on the outside, so that's empty. I think this solves it. 3 remaining. But if this were a mine, if it were a mine, we have to extend out this way to reach to the rest. That will force there to be only one mine here, which will be isolated no matter what, so that doesn't happen. Okay, there you go. Nice. Ching. Ching. Alright, well, we're almost done. We are 1 off from 20. Well, I said we're almost done. We're not almost done. We're pretty far off, but we're 1 away from 20, so let's see if we can get that done, shall we? Alright, connected modulo. Connected means mines must all be connected either diagonally or adjacently. And in addition, adjacent regions of mines must be rectangular in shape. So this L shape or this S shape doesn't work. This one is not connected to the rest of the area or rest of the mine, so it also doesn't work. Modulo. Every clue is the number modulo 3. So if this were a 7, for example, because there's 7 mines around it, it will give a 1 because 7 when divided by 3 gives you a division, gives you a remainder of 1. Yeah. Same for the 0 because 3 divided by 3 is 1, remainder 0. Okay, so let's begin. This 2 and this 0, we can do modular arithmetic here. They differ by this amount, right? And because 2 and 0 differ by, well, something mod 0 minus something mod 2 is basically equal to something mod 3 minus something mod 2. Sorry, something 3 mod 3 minus 2 mod 3, which is equivalent to 1 mod 3. So what we're saying is that this area has an equivalence of 1 mod 3. This is a 1, basically. There's 1 mine here. This one sees exactly a 1, because it can't see anything, I can't see a 4. This 2, seeing 1 must see 1 more. So this has a equivalent of 1 mod 3, ergo just a 1. I said ergo, wow. Well, I mean, if this is a 1, this can't be a mine because it'd be then isolated by connected. So this can't be a mine. Now this one means that's a mine, therefore that's empty. 2 means more of these are mines. Okay, 2 now means those are both mines. 1 must now be a 4, but because there can only be 1 mine in here, there must be 2 mines here to make 4, which gives us a very nice 2-1 pattern. Which gives us that. Now this must be empty because by connected, you cannot have non-rectangular regions. Therefore that's a mine. Okay. Now what? Well, this area must extend out this way, so that's a mine. Therefore no rectangular, all rectangular regions means that's empty. And 2. Well, 2 could be a 5. Or it could be just a 2. Can't be as high as an 8, obviously. But a 5 can't look like this. A 5, in fact, must look like this. And a 2, well, 2 has all empty cells here. The commonality, which is this cell, just can't be a mine. Cool. Okay, now 2 implies that this has an area of 1 mod 4. The 0 differs by that from 2. Differs from that by 2. So what that means is that it must see an equivalence of 2 mod 4. 2 mod 3 here. So 1 mod 3 here, 2 mod 3 here, to make a total of 0 mod 3. Cool. How does it help us? Okay, it doesn't really help, so I'm gonna go somewhere else now. I think the 1 and the 2 down here have some importance, but I don't know how they're linked. This one could be a 4, probably is a 4. What happens if it were a regular 1? Well, then you'd have to have a mine here which would have to be isolated. So that fails. So this 1 is in fact actually a 4. How does that help us? Well, the 4 could reside in here. Empty cell there. But the 4 can't do that. So yeah, if this is empty, then the only way 4 can reside is if I did something like this. That clearly fails this one, which now sees 2. So that means that this must be a mine. This must be empty. This 2 means that's a mine. This 4, well, these can't both be mines, so the 4 must have some number of mines in here, which means that it will complete the 1 that will be empty there. The 0 sees a 1, so 0 is just a 3 then, because it already sees 1 mine, which gives you that. 1 mine in here implies that the 0 must see 1 more, so that's a mine. Finishing this 1 is actually a 4, so that's empty. This 1 sees 2, so it is actually a 4. Okay, however, that therefore means that there are 2 mines in the remaining cells here. That will put some number of mines in here, which would affect the 1 up there. This 1 now can no longer be a straight 1, it must be a 4. Therefore that's empty. This 0 is now a 6. But it can't have 2 mines in these cells because they will form a non-rectangular region. So we can therefore say that this must be a mine. By symmetry, that's also a mine, giving us that. By rectangular region, these can't be mines. 0 here must have 1 mine in here. 2 sees 4 so far, so it must see 1 more, because it can't see 8. Okay, 1 more there implies that this 0 must be a 3, which means these are both mines. Cool. And now, not entirely sure what now. Wherever a mine is, you get connection either way, so nothing much really happens there. Although I can tell you that this cell is empty, because wherever you put a mine, if you put a mine here, then this cell can't be a mine, otherwise you have a non-rectangular region. Same here, if you put a mine here, this can't be a mine, otherwise you get a non-rectangular region. So that means that this is always empty. I guess we don't know anything about that. Okay. This 1 sees 2, so it can't be a 7 clearly, so it must be a 4. This 2 could be a 5, but that will form a non-rectangular region, so this 2 is just a straight up 2. Therefore, there's only 1 mine in here, at most, and therefore the 1 would have to have this mine here, plus this mine here to make 4. That is therefore the case, because that's the maximum you can have. Okay. Now this 2 must be a regular 2. No idea how to solve that though. Interesting. I have something, but I feel like that's really substantial. Alright, let's see. If this were a mine, this would be empty. Right? Sorry, no. If this were a mine, then by rectangular region, this would have to be empty. This would be a mine, this would have to be empty. Okay, now, notice that you somewhat get almost a blockage here. If this were to grow out this way, you would in fact get said blockage. And the only way to not get said blockage is by putting... sorry, let me draw the blockage again. Is by putting a mine there. If the mine was up here, then again, blockage. So the mine has to be there. That would imply this. By rectangular region, that's not a mine. By this too, this must not be a mine. And guess what? Another blockage has opened up. Okay, that was paradoxical. Another blockage has appeared, which puts a mine here. So that just fails. Meaning that this can't be a mine. Alright, cool. Well, this 0 can't be a 6 clearly because it will form 2 non-rectangular regions. Must therefore be a 3. Now, what that therefore means is because of this 1 mine here, there must be another mine here. How does that help? Well, now it doesn't work if this is a mine. If this is a mine, this would be empty. To escape, you need a mine here and a mine there, which already fails a 0. So this can't be a mine. Mine goes there. And then again, one of these are still mines. But we know that this can't be a mine. If this is a mine, these are both empty, forcing a mine here and here by this 2, which isolates it. So there must be some number of mines in here, meaning that that's empty. 1 means that's empty, therefore that's a mine, therefore these are both empty. This 2 means that's a mine. Everything still connects so far. This one has to connect outwards, so that's a mine, that's empty. Therefore that's a mine. And the last cell is that cell, which is also a mine. Sweet. Look at all those pencil markings we made. Ah, pencil markings. They're actually really helpful, actually, those pencil markings. Okay. What am I looking for again? Right. Well, I think that really solves it then. That's all the puzzling we have. 20 is actually really good, I'd say. Because what, we did 4 last episode, which is, compared to now, we've done 6 this episode. Which I'd say is much better than usual. Usual. So yeah. Very cool. Alright. How many of these have we done? 35. Yeah, 35 is quite a lot. Nowhere near our 49 though we're supposed to do. Okay, so looking at the stats now, we have done 835 puzzles. 839? Oh, I guess I got some tea that I never actually got some tea. And I filled out the tea though, right? What extra stuff did I do? I actually don't know what extra stuff I did to lend myself to a higher value. Oh, I put 16 here. This is actually 20. There you go. Okay, 839, right? Yeah. 839 total, which actually brings us to a total of 0.52% of all puzzles in the game done. Yay! Okay, well, that's probably gonna be all for today. I guess I'll catch you guys next time. Hope you enjoyed the video. See you guys next time. Bye bye.